Alright, first things first, I gotta make a chess game. Epic. Alright, check this out. Alright, the game is pretty much done. You can promote pawns, you can, move pieces, all that stuff. So now that we have a working chess game, let's implement this AI. So you're probably wondering, how does a chess AI work? Well, it works with something called Minimax. Very cool. Now I know you're wondering, how does Minimax work? And boy, do I have the answer for you. Minimax is a decision-making algorithm commonly used in game theory and artificial intelligence. It is used to determine the optimal strategy for a player in a two-player... Alright, so basically it generates all the possible moves, and then it gets every single response for each of those moves, and then for each of those moves it gets all the responses, and then for each of those moves it gets all the responses, and then for each of those moves... Alright, so you could probably see the problem with this approach. The tree fills up very quickly. So to get around this, what we do is we set a maximum depth, so it stops the search at a certain point. And in case you're wondering, this is the basic code for Minimax. Alright, so I've implemented Minimax, and this is it with a depth of 5. Let's see how long it takes. Alright. Well, that was kind of slow. Well, luckily for us, there's this thing called alpha-beta pruning. So let's say it's minimizing player's turn here, which means it's maximizing player's turn here. Alright, I implemented alpha-beta pruning, and whoa, okay. I was not expecting it to be that much quicker. So now I think it's time to test him against chess master himself, Martin. Alright, so clearly there's a major issue with my AI. He keeps on repeating moves, and I'm guessing it's because he can't see far enough into the future to know that, well, he's not really doing anything. So I gotta make some changes. So another Minimax optimization is called the transposition table, which basically means there are multiple ways to get to the same board position. So all we gotta do is save each board position and best move in a lookup table, and that way next time we get to that position, we already have the best move. Alright, so I made a little chart to see all of the optimizations and how long each of them take. So let's test it out at a depth of 5. Alright, so there's a huge difference with and without alpha-beta pruning, and then about a 30% reduction in time with the transposition table. Alright, so it's looking alright, but there are still more optimizations we can do. One being move ordering. So basically, if the moves are ordered from best to worst, then it has a higher chance for alpha-beta to actually prune that branch. Now, we don't really know what the best moves are. If we did, we wouldn't really need a chess AI. But what we can do is make pretty decent assumptions to get how good a move probably is. Like, if you could take a queen with a pawn, probably a good move. Or if you can promote a pawn, probably a good move. And here's what the code looks like in case you're interested. And here's the chart after a depth of 4. So it's actually getting pretty good. Now at this point, I researched and experimented for weeks to try and get my AI thinking a little bit better. Now one interesting thought that I had was to recreate the entire AI in a faster programming language and put it onto a very fast computer with multi-threading and create a server side for it so that I can communicate with my front end. And yeah, here it is. Oh my gosh, it works. Alright, let's see if you can beat Martin now. Wow. Alright, that was pretty good. But let's test it against a harder opponent, Antonio. Freaking stalemated. Now, although it was a very interesting idea to use a server, it wasn't very practical in my case. So I spent a very long time thinking and writing things down and experimenting optimizations and how to make it play fairly reasonably. So I rewrote the entire thing with new data structures and functions. And one thing I noticed is it doesn't really know how to play openings. So I need to make a database. Alright, so here I have every single starting move, and it kind of works like our minimax function where it recursively calls itself. Instead of doing every legal move, it does the top 3 moves from Stockfish. So it gets the top 3 moves to a depth of 8. Alright, so that took about 8 hours, 131,000 lines. Alright, I let it run for another about 16 hours to a depth of 15, getting the top 2 moves instead of the top 3 moves. And I ran it to a depth of 50, only doing the best move at each position. And here's the result. So it's got the board hash here, and then a list of all the moves, and here is the function to actually get the moves. So it basically finds the corresponding value and then picks a random move from that list. Alright, let's see if I can beat it. Alright, I'm not gonna lie, he kind of got destroyed. 68% accuracy. Yeah, that was a crazy move. Because then that's check, and then I just pick up the queen. It thinks he's an 850, bro. Come on. Alright, so clearly my AI needs a little bit of help. Now, since the only thing that determines the score in a position is the value of the pieces, then when it searches through the depth, if it can't find a path that wins material, then it'll just make a random move. And a lot of the time, that move isn't very good. So what we have to do is we have to encourage it to make developing moves or positional moves, like pushing a pawn forwards or getting your bishop out there or whatever. Alright, so here I have positional score map, and this is basically for early game and mid game, and then I have one for the late game as well.
Here's one for knights, for example.
Whoa, that looks sick.
More central locations,
Oh, I'm gonna do that. Alright, I wrote some kind of basic code, and here it is. Pawns you generally want towards the center, and then you can push them forwards. If you have a pass pawn, you should keep pushing it forwards. Knights you generally want towards the center, not towards the edge. And for the king, I put them here to encourage castling. After some experimenting, these values seem to make it play pretty well. Alright, so I made some changes. I think it's pretty much done. I fixed a bunch of issues. You can make arrows and stuff. You can, you know, play the game. Alright, let's play a blitz game against it. I'll play as black. See if it could beat me here. Oh gosh, I didn't see that. Let's see what chess.com thinks. Okay, 80% accuracy for him. That's pretty good. Alright, so it plays very well here. Yeah, from now on, it didn't make a single inaccuracy. It just made the best move every single time. From here on. I think I'm on 800, bruh. I'm gonna play a game against it as white this time. Man. That's a crazy checkmate. 83% accuracy with a brilliant move. Bro, 500? Come on, chess.com. Come on, man. Alright, and here's a game I got it to play against Stockfish. Oh my gosh. I beat Stockfish. My AI is officially better than Stockfish. I may or may not have also set Stockfish to like 600 elo. Anyways, guys, if you liked that video, make sure to give it a thumbs up. You know, all that. And if you guys think you can beat it, there will be a link in the description if you want to play against it. Comment below how you did. And yeah, thanks for watching.